So when working with exponents, we want to get things in the same base value. Now remember, when we're dealing with an exponential value, we have, let's say, v to the e. This value, whatever it is, number or not, is the base. And this, obviously, is your exponent or your power. So to compare values in exponential form, we have to get the same base. So here, they say 25 is really a perfect square and can be written as 5 squared. But now 5 squared to the 19th is a power to a power, and those multiply, and we see this 5 to the 30, sorry, not 28, 5 to the 38th now is not equal to the 5 to the 28th, and we can compare which would be bigger. Well, we know it's not equal. Which of these values would be bigger?
25 to the 19th.
Yeah, 25 to the 19th, which really turns into 5 to the 38th. So we can end up saying 5 to the 28th is less than 5 to the 38th, or we could still write it as 25 to the 19th, but we'd rather compare them having the same base. So I'm going to help you through A, and then I'm going to have you guys do B on your own probably. Sorry that cleared and did not capture. I probably need to reorient this considering it's morning. What base do you think we should choose when we're working with the start values of 3 and 9 and 3?
9.
So is it easier to convert values smaller or easier to make them bigger? And really, if you think about measurement or anything else, not what's best for the situation, but what's easier, it's always easier to go smaller. So, Andrew, what do you think we want to do here?
We want to use like 3, but 9 is really just 3 to the second.
So write this all out on your paper. Nothing's going to happen with 3 to the 18th, so go ahead and keep it. 9 turns into 3 squared. Please put that in parentheses. Trust me, it will help you. So the only thing we change there is we turn 9 into 3 squared. Now, we need to evaluate that because it's a power to a power. So again, 3 to the 18th, nothing happens. And what does this first...
3 to the 20th.
3 to the 20th times 3 to the 3rd.
Which is 3 to the 23rd.
Is everybody with us how we get that turns into 3 to the 23rd? So now what I'm really comparing, and I'm just going to write this above here, is 3 to the 18th compared to 3 to the 23rd. Which one of those is going to be bigger?
3 to the 23rd.
Bigger power, as long as my base is not a fraction. Then the bigger power is the bigger value.
Is the smaller value.
Bigger power is bigger value.
Unless it's a fraction, but then you said...
Right, I said as long as it's not a fraction.
Yeah, and then you said that then the bigger power...
Is the bigger value. It is.
As a fraction.
No, I'm not talking as a fraction because we're not looking at fractions yet. What we're dealing with right now is just base is a number, not a fraction. Bigger power is bigger number.
Didn't we already look at fractions?
We know how to do that, but then bigger power is smaller number when we're working with fractions. Yeah.
Why did you square it?
What do you mean
Like
square?
3 squared to the 10th power.
Because this 9, it's not so much that we squared it, we converted 9 to a value with a base of 3.
Oh.
So the 9 to the 10th, 9 is 3 squared. So this 3 squared is 9 to the 10th.
Oh, okay, so they're just equal.
Yeah.
Okay.
All I'm doing is rewriting this in a different form. So try B on your own. Decide what base you should use. Convert how you need to with everything. If your bases are the same, you don't need a calculator to evaluate this. I'm not picking on you, I'm just saying, like, you could evaluate them how they are and then just compare. But if we can get the bases to be the same, we don't need a calculation, we don't need to do any of the math. we can just compare it in the exponential form. So Noah, what base are we going to choose here? Starting with 4, 2, and 8 as our bases.
2.
Choose 2 because 8 can be written as a power of 2, and 4 can be written as a power of 2. So Ozzy, how do I rewrite this stuff as I go through?
You just which one on B?
The whole thing. So what does 4 to the 21st turn into to begin with?
2 squared.
Yeah. So this is 2 squared to the 21st. This is still 2 to the 28th. And our 8, what's it turn into, Ozzy? 2 cubed to the 4th.
Excuse this interruption. Could I please have Jaslyn to the office? Jaslyn?
So Sam, what does my 2 squared to the 21st turn into?
2 squared, 2 to the 42nd.
2 to the 42nd. Dom, what does my 2 to the 3rd to the 4th turn into?
2 to the 40th.
So listen again. What does my 2 to the 3rd to the 4th? We'll get there. So what's this turn into? 2 to the 12th. Then 2 to the 28th and 2 to the 12th make 2 to the 40th. So then, Whitney, what inequality symbol would go in between them to finish us? The greater than. Any questions here? We got them both into a base of 2, so then the higher power is going to be the higher value. Unless your base is a fraction. Try to got it on your own. This one's a tiny bit tricky, depending. Anish, what base do you choose here when you start looking at 27, 9, and 3?
I choose 3.
Yeah, the smallest base that we can represent all of them in. So what's 27 turn into in terms of a 3?
3, 15.
Ooh, yeah, so you gave me a little bit more than I asked. 27,
Is there,
yeah. 3 to the 3rd to the 5th.
and then you convert 9 into 3 to 7 times 8, which is 316 divided by 3.
So this becomes 3/16. The denominator is still 3/4. So this whole thing is 3 to the 12th. Make sure you say to the, because if you just say 3/12, people are going to be like, are you talking about fraction or what? So 3 to the 12th, and somebody on the left side already said, I think it was Anish, 3 to the 15th. Which inequality symbol goes in between there, anybody? Greater than. Any questions? You feeling pretty good about this? Love it. Especially if I give you a little bit of time to work on your homework today in class, assuming like if we get done with this stuff. Do you guys think we'd be ready to take the mastery tomorrow?
Yes.
So here's the deal. Anybody that's going to robotics is gone Thursday. Well, anybody who's going on Thursday is gone on Thursday. So some of our classmates need to take the test tomorrow. So we've been moving really fast sort of thing. I'm debating what to do with the next couple days because Friday is a weird schedule. So if we took it tomorrow, then potentially Thursday, Friday, we'd like watch a documentary or something.
What about a review game tomorrow and then on Thursday we take the test?
Well, the problem is some people will be taking the. Who needs to take the test tomorrow? Who's going to robotics on Thursday? You're not here. I swear more people talk to me. Maybe it was Math 7 people. Nobody else in here is going to robotics on Thursday?
I could do
Hey, you're gone Friday. That's what you were talking to me about.
I could just take it in air extension.
Yeah, that could work too.
So
I
if
mean, you could even probably take it today at extensions.
yeah, and if
You're
you
probably ready.
if you do something like unimportant on Thursday, that it probably won't have to like take this.
Right, then you have nothing to make up,
Yeah.
is what I was thinking. Stay tuned, because it's awkward that we're finishing a chapter with like a day to spare before spring break. So that's why this is just getting kind of awkward. So, here's just a little set of your powers of 2 and your powers of 4. What do you notice comparatively? Just stick up your hands. Ozzy, what do you notice?
They're equal, like, with the powers of 4.
Like the output values here, right? So if we look at what this gets, I'm getting 16 on both sides. I'm getting 64 on both sides. Their outputs are equal. Okay.
And every time the power is doubled.
Okay. Oh, so you mean? Sorry, define that a little bit more, because
Like if it's 4 to the second and it's 2 to the fourth, the 2 multiplies by itself and it's 4.
So that power is double the power on the 4. So if we are given 4 to the 15th, what do we think the power of 2 would be to make this true, Sean? 2 to the 30th, because we know 4 to the 15th is really 2 squared to the 15th, which becomes 2 to the 30th, which is how we know that x is going to equal 30. Any questions on why that works? And this will work with any set like that.
What are the sets like that? Are there like specific things where the sets are so
You like, you're so awesome, and it's funny because it's like, I don't even know how to describe it. You're like in my brain. It's because literally as quick as I could capture and write it out, I was going to ask you guys, what's another set like that? So if I gave you, and you can jot this like somewhere off to the side, I guess. If I gave you 9 to the 13th, just use unlucky 13. What related value could I use just like I did with the 4 and the 2? So we need to identify what will the base related to 9?
18?
3, right? Because here, 2 is the square root of 4. And that's why that power rule works. Because when I square root the base, I have to double the power, and I'd get 3 to the 26. What about 16 to the 8th? What would the next related base? Colin?
4 to the second.
Ooh, not so.
4 to 2.
Well, it would be 4 squared, but 4 squared to the 8th, and 4 squared to the 8th would actually become 4 to the 16th. This one often messes with people, because when you see the 16 and the 8, for some reason, some people say like, oh, I can use 8 as the base. No, be careful. Square rooting is not the same as halving. Now, I could actually keep going. I could make this 2 to the 32nd. So what I'm trying to get you to see here is if you square root the base, you double the power. Square root the base, double the power. So that's a pattern that will work no matter what. If you square root your base, you just double your power, and you have equivalent values. Any questions there? So, the length and width of the rectangle are given to us. Our length is a linear expression, -5x, and our, well, depending on which way you look at it, our other value is exponential, 3 times x squared. Take a moment. Try to write an expression to represent the area of this rectangle. Area is normally easy, but now we're working with some interesting terms. So, Lena, when we set this up, what are we going to want to do?
You have to do like 3x to the power of 2 times -5x.
Ooh, so we're going to take our 3x squared times the -5x. Agreed. Now, we know that because we're mathematicians, we need to write this in a simpler form. This is kind of messy. So think about this, and if you haven't written it like this, please do so. This is 3 times x squared times negative 5 times x. All because these don't show the multiplication symbols in between does not mean that they're one value. This is a term made up of 2 different values, a 3 and an x squared. So Andrew, what can we do over there to clean things
So
up?
I was gonna say get rid of the x's, but one has an exponent, so you can't really, well, you could, because x should attach to 3.
What does x squared tell me?
X times x.
So this is really 3 times x times negative 5. Sorry, make sure that's a multiplication dot. So now my x doesn't have a power. It's just I've got more x's. Moon, what do you think?
Would you add the x's together?
Careful saying add. I can put the x's together.
Yeah.
What is one of our standard rules about multiplication? Jeremiah? No, just in general. What about multiplication?
Repeat it.
Different than subtraction. What can I do with multiplication that I can't do with subtraction?
Divide.
What's the difference between 2 times 3 and 3 times 2?
Oh yeah, switch them.
Ah, I can change the order however I want. So this is really 3 times negative 5. My brain is getting ahead of itself. Times x times x times x. And really, that turns into
Negative 15 times x cubed.
now this gets really complicated because my area is a negative value. Area can't be negative. But right now, hold on, this value is still unknown. So I have a negative times something that I don't know. And that has to equal my area. What must be true about x cubed?
It needs to be a negative number.
Yeah, and I think I had a lot of hands up, so make sure, especially like sometimes I'm using the cards, Monica, and sometimes I'm calling on hands, but you can't really just shout out. So this x cubed must also be a negative.
Would it be safe to assume it is?
No, you can't assume anything.
But it would make sense if it wasn't.
Assuming
Yeah,
things gets you thrown out of mathematics. Like, you just get kicked right out. You cannot assume anything. You have to make it happen. Anyone ever watch Star Trek?
No.
Yeah.
Make it so, number 1.
Oh.
So you have to make it so. You have to make it happen. So, to make x cubed negative, what has to be true? So down here in part B, go ahead and write to make. Can't write today. Just struggling. To make x cubed negative x minus
X has to be equal to a negative because a negative times a negative times a negative is 10.
So how could we mathematically make a statement to say x has to be a negative value?
X is equal to a negative.
Don't say equal to. Because when you say equal to, you're starting to give like a value. We have a range of values that we can use, right?
X is less than or equal. No,
Not equal.
is less than 0.
If x is less than 0, that means it's negative. And without the equal, that tells you, well, 0 doesn't work, but anything under 0 works. So, for this situation to be true, x has to be less than 0. Does that make sense?
Yeah.
Because area can't be a negative number. So we have to be able to get a positive output. Cool. No, it could be negative 8,724, or it could be negative 2. Doesn't make a difference. Now, the difference it will make is the size of the rectangle. Because notice, negative times negative, that would give me a positive length. What happens when I have a negative squared?
Positive.
Becomes positive times a positive gives me a positive length. So I need positive lengths, length or width or whatever you call it. I need positive distances to make this a true shape.
Couldn't you just absolute value it?
I mean, we can't because what we started with here. Like, we weren't given anything having to do with absolute values. So, if this said, like, negative 5 times the absolute value of x, that would actually be terrible. That would never work. So think about if somebody told you a width was negative 5 times the absolute value of x. That's always going to be negative.
Yeah.
That can't
That
work.
would have to be an actual 5 and a positive 5.
Right, so yeah, with this negative, this would never work out. Alright, we cool on this one.
We can. Cool.
Do you keep your cucumbers in the fridge?
Yes, yes I do.
I don't love cucumbers. We
I
don't
love
see
cucumbers.
Try the next 3 on your own. I'll give you maybe 3 minutes. I doubt it though. At max. It's a lost colored pencil. And it's one of mine.
Ooh, dun, dun, dun.
Siesta. Oh, by the way, at the end of class, I got papers to pass back, but also remind me I got a story to tell you guys. If I can send myself a couple screenshots really quick, then the story will
I thought you were
be better.
going to say like we're having a fire.
No, it was about me helping a friend with math, but not having any paper to write things down on, so like
Oh no.
my confidence was lacking. So I went to the baseball game last night, and a buddy of mine texted me a math problem, and I was like, no paper. I'm just there with my phone, my camera, and just like the stands. So, because I was gonna take a picture, but our kid didn't get in last night. But while I was there, so he wanted to know the volume of 2 objects. So I'll show you the messages here in a bit.
Well, can you just text it?
Yeah, but to do volume calculations, you got to find the area of the base, you got to multiply by the height, and then he wanted it converted into gallons, where he gave me inches to start with, and that creates a whole nother thing.
Oh my goodness.
So,
Did you?
yeah, I did it, because I'm the math friend that all my friends text like math problems through, like, hey, I need to know blah, blah. And so I'll show you here in a minute. So, for what values m is the expression reasonable in representing the area of a rectangle? Mr. Smith, what do you think? If m is getting raised to the 5th. So, let's start to think about what values work, what values don't. Will positive numbers work to represent area if we said area is 3 times m to the 5th? What happens when you take a positive number to the 5th? Will you get a positive or a negative?
Positive.
Positive. And when we look at this expression, we can say, okay, m to the 5th needs to be, does it need to be positive or need to be negative? It needs to be positive. So, positive values work. What if I plug in a negative value there, Jeremiah?
It won't
Why?
Because it would make it like impossible. You would have to just like, you can't have something that's not there.
So, negative times negative makes a positive. Negative times negative makes a positive. One more multiplication by negative makes it negative, and that won't work. So, the restricting statement we can say here is M, what? What do we say about M? M has to
Be positive.
Well,
It needs to be
Greater than
zero.
greater than 0. That's how we represent being positive.
Wait, how's this reasonable in representing the area of a rectangle?
Because it has to be positive. Area cannot be negative. So, and this is what I love. When you get into design, people start talking about negative space. And I love telling people, like, that's impossible. But what negative space means is the lack of something. So it's really empty space they're talking about. So if I make a design and I make a shirt logo, let's say like these guys wearing these shirts, the 4 and the line and the 1, that would be ink, but the space around it would be negative space. So if you wanted to use that to come through your image and look like the eye of an animal or look like something on the image, that's called negative space, but it's really a misnomer because you can't have negative space. Like, that doesn't make sense. There are black holes, and that gets into the whole, like, how space is stretched, but that's too deep for us today.
Did you go to the girls' lacrosse game yesterday?
I did not. I tried to go to a baseball game yesterday to take pictures, and our guy did not get in. I'm going to girls lacrosse. I don't know. Ask me later, and I'll show you my calendar. Probably, yeah, I think so, because I don't work on Wednesday. Mr. Hoover. For what values of A would A be to the second power equal A times B to the second power?
Well, I was gonna say any, but I think because the second power is multiplying B and A, so
Now be careful saying multiplying. It's applying.
So I think no, not 0, 1, maybe,
Ooh.
because I was gonna say any, but since it's multiplying, it's gonna be B to the second and then A to the.
So, hold on. Let's write out a step. So Andrew told us the power applies to both. This is really A squared, B squared equals A times B squared.
So yeah, then A has to
What's the same on both sides?
B squared.
B squared, B squared. So let's not B squared. Let's get rid of it. Some of you got the small joke.
What?
So now what we see is A squared must equal A. For what values does A squared equal A? 1
0.
and 0.
Oh, wait,
Because 0 times itself is 0. So A could equal 0 or 1. What about negative 1?
Yes. Maybe?
No.
No, do not fall in the trap door. Negative 1 squared is what? Positive 1. Whereas negative 1 would just be negative. So be careful. And our last one here, Ashley, give me a second to capture and clear. I do not want to do something else. Alright guys, keep your attention please. So Ashley, I have this. I'm going to write it up here. Negative 3A squared equals negative 243. And I want to evaluate what can A equal. So we really want to isolate A. What could we do first to start isolating the A? I'm talking to Ashley, by the way, if you guys missed that. Get rid of the negative 3. How could I do that? Boom. So we on both sides divide by negative 3. This is going to give us that A squared must equal, well, negative divided by negative becomes positive. Break this up. What's 24 divided by 3? 8, but really it's 80 because there's an extra 0. And then 3 divided by 3 gives me the 1. 81. So, Ashley, what could A be to get 81 when we square it? Positive what? what number, when squared, makes 81? Ooh. So A,
It's W.
is it only positive 9?
Yes.
You can't know. No, you can't.
What happens if I square a
It
negative?
turns positive, so you can.
It turns positive. So how we write that is positive or negative. You put both symbols. This means positive or negative. When you put a plus over a minus,
Can you do that on our calculator? Would that work?
no. Your calculator does not have that symbol. So this is when you are writing, and instead of, because we could say A equals positive 9 or negative 9, but that's annoying. We'd rather be more efficient than that.
It's just lazy.
And we write positive or negative 9. So we have about 10 minutes left. If you'd like to get a Chromebook, you can quietly go over to Mrs. Gordon's room and grab a Chromebook to work on some homework.
Actually, ours on this phone.